going to start with the normal distribution, okay, and the normal curve. So, a couple of vocab terms for us, all right? A distribution is basically just a set of data. Just a bunch of numbers, data points. That's my distribution, yeah? All right, and I know you guys have learned about, what is that, central tendencies? Is that what they call it? The mean, median, mode, range, all that stuff, right?
Yeah.
So with distributions, well, for our sake, I guess, we're only going to look at 3 parts that are kind of important, right? The mean. What is another word for the mean?
Middle? No, that's median.
Good. Median is the middle. What is the mean?
It's like all the numbers, like, what else is it called? It's like an order.
Okay, so all the numbers, I'm going to give you a hint. So that would just, see, that's how you find the median. So the mean is you add up all the numbers and then you divide it by the total amount of data points that you just added up. You know, you guys actually use this like pretty frequently in your lives, probably. You're already confused.
No, I always got that confused.
Yeah. Okay, so now you're going back to the median. You guys must have focused a lot on the median in Algebra 1, huh?
No, it's just the easiest algebra, huh?
Yeah. Well, the mean is basically, it's the average. Okay? The mean is the average. You take all of your data points, you add them all up, and then you divide it by how many you have, right?
Like science.
Yeah. So it's the average. Here's the thing, though. The symbol for this is that guy. It's a little,
mu, right?
huh?
Mu.
Yes, this is mu. Good.
Think of a cow every time I think about it.
Yeah, it looks like a U with a little tail in front. So we're going to put a little, I don't know if that's how you spell it, but phonetically it works. Mu.
Yeah.
My algebra teacher said thinking this meow because the little M thing looks like cat's ears.
Oh, here?
Yeah.
Because that works too. So the mu on your calculator is, you know, worth noting that it's X bar. X with a little bar above it, that means your mean or your average, okay? On your calculator. So now your median, now you guys told me this, is the what? Which number?
The middle.
Yeah. The middle number. But just the random order middle number? No, it has to be in order from the least to the greatest, right? Okay. So the middle number, and I'm going to put in order, right? And what the symbol for this, guys, is just a capital M. But in your calculator, it will say MED. Right? MED for median. Ethan, you with us? So the standard deviation, right? Do you guys remember learning about that? Did you learn about that in Algebra 1? Yeah, standard deviation. So the standard deviation is the spread, or how far your points are from the mean, okay? Spread of, let's say, data from the mean, okay?
So is this the deviation from the line of best fit? The line of best fit.
from the. All right. So for standard deviation, the symbol is this guy.
It's like an R.
It looks like, I know, you're right, it does kind of look like an R. I always thought of it as like a little tadpole.
Is that a mega or no?
No, that's sigma. It's lowercase sigma. Alright? And I guess this is worth noting too. In the calculator, I mean, it looks very similar. It just has that with an X to it, okay? And I'll show you how to get all of these straight from your calculator. Yeah. I mean, look, isn't this so great? I gave you guys all of the instructions with pictures. So good. So, basically, all of your commands for this are found in the stat menu, all right? Just like we did, Tom, like you said, with that reg stuff, the best fit. We go in the stat, we hit enter, and we see these lists, right? You need to make sure you have L1 showing, okay? Now, what you're going to do is you're going to put in all of your data points into L1, all right? Where, you know, before with the best fit stuff, we used 2 lists. This time we're only going to use 1. Now, in order to find the mean, the standard deviation, and the median, after you put in all your data, you're going to go to Stat Calc, okay? And from Stat Calc, you're going to select 1 bar stats, all right?
If you hit second calc, does it do the same thing, or you have to bar over to calc?
No, you have to tab over to Calc, all right? So let's try this together, okay? I mean, you have all the instructions right there, but let's try number 1. Let's put in all of these data points into L1. So go to Stat, go to Edit, and put in all of your data points, just like I have here. You should have 9. So now that all of our points are in, I'm going to go back to Stat, go to Calc, and then that first option, 1 bar stats, that's what I'm going to click. And look at that, right? X bar, the first one, that's your mu.
I know in the bottom part of it. Isn't the bottom part for a box and what's the plot?
Yep, because it has the lower and upper quartiles, yep. So we have mu.
We're gonna do those too.
No. And we have our median. All right. So we have our mu, we have our sigma, and we have our median. Yes? So this is all for number 1. So mu equals 14.01, sigma equals 5.91, and the median equals 16.2. Can you guys find the mu, sigma, and the median for number 2, please? So you should have 9.63 because it's 2.5, right? And then your mu is 7.31. And what is your median?
6.
Good. Perfect. So that's what you have for number 2, or you should have for number 2. All right. So let's talk about normal distributions. Oh, which, by the way, if you do not get the same numbers, then just go back to Stat, Edit, and make sure that you have all of the data points. So some things about normal distributions. Guys, normal distributions look like this, okay? This is called a bell curve, all right? So the bell curve represents a normal distribution. The total probability underneath that curve, right? So the whole thing is 100%, right? 100% is a whole of like whatever it is that you're talking about. But since we're talking about probability, not talking about percentage, so the total probability underneath that curve is 1. Okay? And it's nice because you see how there's this long line right here, right in the middle, right? That's your mean. Right in the middle, that's your mu. Okay? And to the left of that, that's exactly 1/2. And to the right of it, that's exactly 1/2. The mean of a normal distribution is at 0, and standard deviation is 1. Okay? That is, if they do not give you any numbers for the mean and all that, but they just tell you it's a normal distribution, it starts at 0, standard deviation 1. Okay? So now, when you're given a set of data that is normally distributed, and they'll tell you, all right, the mu is at the center of the bell curve, right? The mu, or your mean, you could write mean too, so you remember, is right at the middle or the center of the bell curve, and the standard deviation is counted from the mean, and that's plus minus 3 in each direction. Okay, we only do 3 standard deviations. Oh, I think you guys are gonna like this. You ready? For a math class, the average score on the test was 82. Okay, average, right? That means mu equals 82. And the standard deviation of the normally distributed scores was 5. So sigma equals 5. Sketch a normal curve showing the test scores and 3 standard deviations from the mean. All right, this is what it means, okay? So what we're doing is we took all this information, right? Now, right in the middle, okay? Right in the middle, that's where my mu, my average goes, 82. All right? Now, the standard deviation is 5. That means standard deviation is how many from the mean, or how much from the mean, right? How far away is it? So if it's 1 standard deviation away, we're right here. 1 standard deviation, is this above or below? Above the mean, right? So since it goes above, well then I need to add my standard deviation. What's 82 plus 5? 87. That's 1 standard deviation. Yeah? I told you we go up to 3. So 2 standard deviations. Yeah, just add 5 again. No, 92. And then that's 1, 2, and then 3 standard deviations. Plus 5. 92 plus 5. 97, right? Good. So that's 3 standard deviations above, right? But we also have to do the below. So 1 standard deviation below the mean. What do you think you're going to do? You think you're still going to add the 5? Subtract. Yeah, because now you're going below the mean, right? So what's 82 minus 5?
78.
And what's 2 standard deviations below the mean?
72.
72. And what's 3 standard deviations below the mean?
67.
Yeah. So there you go. You did it. Alright. If I'm talking about 1 standard deviation from the mean, I'm talking about one above and one below, okay? It doesn't mean just in one direction unless they specifically say that, all right? So look at number 2. The scores on the last quiz follow a normal distribution. The average is 29 and the standard deviation is 3. Mu is 29, sigma equals 3. Let's label our points or our, normal distribution here. All right. What is one standard deviation above? What score? I just want to make sure you guys are understanding. You guys getting it?
Yeah.
Yeah, you know what you're doing? Okay, well then let me label here and then we'll make sure it matches. What'd you say, Tom? Good. Alright. So now look at what the question's asking you. It says, what is the range of scores that lie within one standard deviation from the mean?
So you shade in the 2 areas up there and top of the
There's your mean. Yeah. Well, you know I probably shouldn't do that. There we go. So this is your mean. One standard deviation means one above here and one below here. Yeah, so you're right. 26 to 32. B. Do you guys get that too? Good.
I kind of like this, like it, you can see how it is.
Good. I mean, it should make a little bit more sense. Like, it should feel a little bit more intuitive. Yeah?
Don't like some, because like say like for some stuff like they on a bell curve, having the test scores go like that, that doesn't really make any sense.
Oh, okay. So,
I mean, there's no limit
Because
to
it
what you
counts
can
for a
make.
good quarter, doesn't it?
all right. So then let's get back to this. Let's talk about something called the empirical rule. So the empirical rule, guys, is known as the 68, 95, 99.7 rule. Why? Why? Well, because it goes in this order, okay? One standard deviation. If it's in one standard deviation, it means that 68% of your data points are in there. One standard deviation. That means one to the left and one to the right of your mean, right? That's 68% of your data. Two standard deviations accounts for 95%. You have to memorize this. 68, 95. And then 3 standard deviations is 99.7%. Which makes sense. The further away you get from the mean, the more data points you're talking about, right? So basically, it tells you that for a normal curve, we can assume that most of our data, or 99% of it, is going to fall between 3 standard deviations from the mean. Okay? Alright, so what does that mean? Well, there's my mu, right? Now, 1 and 1. 1 standard deviation, yeah? That's 68%, approximately 68% of your data. Yeah? That's what this empirical rule is saying. Now, 2 standard deviations. Well, then now you're at 95% of your data, which makes sense. That's more of this curve that the space is taken up, right? And then 3 standard deviations. Oh my, look at that. That's basically all of the graph, right? Like all that, yeah? 3 standard deviations is 99.7. Right? And I'm putting an arrow meaning this whole entire purple part. Okay? You know, do you notice that it doesn't quite hit 100%? Right? It's 0.3 away from being 100%, right? That we're leaving for these outliers here. Right? Those are the extreme points. The super low points and the super high points. Okay? You know what else is norm? IQ. Yeah? You know, for IQ scores, 100 is the mean. So from 100, huh? Yeah. Is well, I guess it depends on which test they do, which battery, but generally 100, and the standard deviation is 15. That's pretty cool. So if you have so it goes 100, 115, 130, right? If you have an IQ of 130, you're 2 standard deviations above the mean. You're very smart. Whereas on the other side, right? If your IQ is what, 85, 15, 70, 70, I'm sure is when they used to say you were, you don't use that word anymore, but intellectually disabled. It was like mentally retarded before, but they don't use that, not PC. You know? So,
Different era now.
I know. Well, here's the thing, as long as you don't use it in a, you know.
I mean, we live in different. People are more PG minded. That's all.
Alright, so here's an example that I would like to try with you guys. On the last Algebra 2 test, students' scores represented a normal curve. After analyzing the test results, we found that mu equals 80% with a standard deviation of 5. Yes? So, A says label the normal curve based on the data provided. Alright guys.
We should go 80, 85, 90. And
So, yeah, alright, let's do it. 80, right in the middle. That's your mu. Yeah? So 1, 2, 3 standard deviations above, and 1, 2, 3 standard deviations below. I want you to label those, please.
65, 70.
Wait, 85, 90, 95. That takes care of the standard deviations above the mean. What about below?
65, 70.
No, go from the mean.
75.
Uh-huh.
70. 65.
Good. So guys, let's think about this. So 68% of the students scored between what and what? Yeah.
75 and 85.
Good. 75 and 85 because that is 1 standard deviation above and 1 standard deviation below, right? So 75% to 85%, yeah?
And then 95% students score between 70% and 90%.
70% to 90%. You know, does anyone have any questions about this? Are you guys okay? Oh, so good. All right, and then the last one, Tom. 99.7% of students.
Scores between 65% and 95%.
Good.
Why can't we put the lowest score and then like the highest score, like 50 to 100? It doesn't work like that.
What do you mean?
Like we don't put the lowest possible and then the highest one. That's the
No, the lowest possible could be a 0, right? Not at our school, but, you know, technically, yeah, it could be a 0, right? 50%.
I mean, people still failing. It doesn't really matter.
Right? No, it doesn't. 50 still enough.
Yeah.
60 still enough. All right, questions about this?
Why is 60 still an F though?
64 is a D.
Dude, I'm better off at the zero than the regular word was.
We can use the empirical rule to break down the normal curve even more, right? Each of those bars has its own percentage, okay? And we can do that because the normal curve is symmetrical, is completely symmetrical. So I'm going to show you how we can break this down. Yeah? Oh, so did you get that? Symmetrical?
Yeah.
All right. All right, so of course we know that right in the middle is our mean, yes? Yeah? Okay, so one above and one below, yeah? Guys, one above and one below, this whole thing is how much percent-wise, according to the empirical rule?
Around 68%.
68, right? The empirical rule says one standard deviation above and below is 68%. Well, then 68 is two of these bars. How do I figure out one? Divided by what?
By 2.
Yeah, cut it in half, divided by 2. What do we get?
34.
34.
So each little bar is 34%.
Each
It's only
little one is
It's
34.
only the first two bars.
Yeah, because that's just your first standard deviation, right?
So the next one you cut it into 4 pieces.
No, you can make it even easier than that. Do you guys see where we got the 34?
Yeah.
All right, so I'm going to show you this one too. So 2 standard deviations below the mean and 2 standard deviations above the mean, right?
95.
Is 95. Yeah? So think about that. You have 95% for the 2. That's this whole thing. All 4 bars, right?
Yeah.
But what do you already know? You know that these 2 bars from your first standard, your 1 standard deviation is what percent? 34 plus 34, which is what? 68. So subtract that 68 out of there. What do you get? 27. So then that tells me that 27 is this bar and this bar added together gives me 27. Do you see that? Right? This one and this one added together gives me 27. How do I figure it out for just one? Divide by what? 2. Divide by 2 gives me what? 13.5. Good. So this one, 13.5. You know what? I can't do that. So I'm just going to erase a little bit from here and just write that in. Yeah? 13.5. Use a different color. 13. Yeah? Isn't that pretty good? Do you see what's happening? All right, so then the last one, your 3 standard deviations.
Then you take the 34 and subtract the 13.
So then 3 standard deviations is what, according to your empirical rule?
99.7.
99.7. But what do you already know inside this 3?
One bar is 34 and the other one is 13.5.
Okay, but think bigger.
The
You
whole
know
bar is 68.
2. You know 2 standard deviations.
68 and 27. And then
Okay. 2 standard deviations is what percentage?
95.
95. So just do this minus the 95%. What do you get? 4.7. But that means that it's these 2 little bars here. I want the value for 1. So what do I have to do? Divide by 2.
2.35.
2.35. So in here it's 2.35%. And in here, 2.35%. Does that make sense? you're basically subtracting out the one right before it and then dividing it in half, right? So, big question for you guys. You know, the whole thing does have to add up to give you 100. So we have these little outliers. Think about it. If your big picture is 100, what is the one right before 100? 99.7, right? That's 3 standard deviations. So minus 99.7 gives me what? What's 100 minus 99.7?
0.3.
0.3. Now divide that by 2. What do you get? 0.15. So this 0.15%. Remember, these are all percentages. And this guy is 0.15%. I'm going to show you something cool here, okay? The whole thing is 100%, right? See how we broke it all down like this? It would be in your best interest to remember how to find these separate bars, or at least memorize it, right? Something. But I want you to tell me what this plus this plus this plus this gives you. Just that half of your bell curve. Add up each of those bars. Tell me what you get. Did you get 50? 50%. You know why? Perfectly symmetrical. 1/2 of your bell curve is exactly 50%. The other half is exactly 50%. Yes? So sometimes if you're trying to figure out, like, oh, what's all this? If you know 34, maybe you could subtract it out of 50. Yeah? I'll show you what that means in this next part. Going back to our example, okay? The next page. What percentage of students scored between 85 and 90%, guys? Where is it? 85 is here, and 90 is here. So between that, you're here, right? Guys, what percentage of kids or students score between there?
13.5.
13.5, good. Right? Because this one's 34, that one's 13.5. Right? And we can label it again if we want. 34, 34, 13.5. Sometimes it helps us if we like write it a bunch of times, right? What comes after 13.5? There's 2.35. 2.35. And then the outliers are 0.15, right? Way over here. I'll put it way over there. So the next one is asking, what percentage of students scored below 75%? Okay, so below. Here's 75 right here. So this one plus that one plus the outlier. Or, what'd you say, Tom?
50 minus 34.
Yeah. You know that from here on, that's 50%, right? Yeah? So you could do 50 and just take away that first one that's not shaded. Yeah. 50 minus 34 equals 16%, yes? How's that? Or you could add it. You could add 13.5, 2.35, and 0.15. It doesn't matter. All right. Now look at the next one. What percentage of students scored higher than 85%?
50.
Hmm? Is it 16% again?
Mm-hmm.
Where is 85? Right here. So this one higher than that, so that one and that. Yeah, right? Because on the right hand side it's 50%, but I took away the 34, so yes. So again, this is 16%. So 16% either way. Yes? Questions about this? All right. So let's look at practice problem here, number 1. All right, which description of a normal distribution is most likely not true? Let's go through each of these. Guys, keep in mind, this is not true. Which one is false, right? So A, approximately 99.7% of the data will fall within 3 standard deviations of the mean. True or false? True. Right? This one's true, so that one's out. How about B? Approximately 95% of the data will fall within 2 standard deviations of the mean. True or false? True. So that's out, because this is true. And C, approximately 68% of the data will fall within 1 standard deviation of the mean. True or false? Huh? 68, 1 standard deviation, is that true? Yeah. Because remember, 1, 2, and 3 go to 68, 95, 99.7, right? Yeah, so that one's true. So then look at this. Approximately 34% of the data will fall within 1 standard deviation of the mean. No, it's only like 1 either going below or above the mean, right? So this one. When we say 1 standard deviation from the mean, it could be below or it could be above. All right? So let's look at number 2. A normal distribution of data has a mean of 0 and a standard deviation of 0.75. What percent of the data would be expected to be between negative 1.5 and 1.5? Draw your curve. So mean of 0, standard deviation of 0.75, right? Zero. Yes? Standard deviation, you want to do 1, 2, 3, 1, 2, 3. Yeah? The one above, you add. So 0.75. And then is what? 1.5. And then 2.25. Did I do that right? Negative 0.75 going the other way. Negative 1.5 and negative 2.25. Yeah? So, oh, okay. So, what percent of the data would be expected to be between negative 1.5, so from here to 1.5 here? Think about it. Look, from here, 1, 2. Isn't that 2 standard deviations above? And then 1, 2. Isn't that negative or 2 standard deviations below? Right? What percent for 2 standard deviations from the mean? Because it's like perfect. What percent of data is this, guys? According to the empirical rule. Huh? According to the empirical rule, 2 standard deviations is 95%. Okay? What happened? Yeah, just got tired? Oh no. All right. Okay, we can do this one. So the number of hours that students studied for their Unit 6 test was normally distributed. So apparently they went and asked 90 students, right? And they said that out of the 90 that they asked, the mean number of hours they studied was 5. And the standard deviation was a half hour, so 0.5, right? So out of the 90 students surveyed, what percentage of the students studied for 6 hours or more? I mean, you think that's going to be a lot, or you think it's going to be a little bit? Studying for 6 hours, that might be an outlier type of situation, right? All right, well, just kind of, keep in mind what you think would be a reasonable or an expected percentage, right? 5, 1, 2, 3, 1, 2, 3. If it's going up by half an hour, then it's 5.5, 6, and 6.5, yes? If it's going down by half an hour, then it's 4.5, 4, and 3.5, yes? All right, Tom, you writing any of this down? So it says, what percentage of the students study for 6 hours or more? Well, 6 is here. So they want this, and they want this. 1, 2, 3. Oh, and then the little outlier. Yeah, you can add them. Or you can subtract it out of 50. It doesn't matter because you have these 2 spots. You know what I mean? So this is 34. This is 13.5. This is 2.35. This is what? Wait a second, hold on. 1, 2, 3. Then that's 0.15, isn't it? Right? That was the outlier right there, 0.15. Yes? So what is 2.35 plus 0.15? Huh? No, what is 2.35 plus 0.15? 2.5. So only 2.5% of the students that they asked studied for more than 6 hours. You never studied a day in your life. Oh my goodness. Oh no. So guys, your test corrections are due. Well, supposedly it was supposed to be tomorrow, but I'll take it on Wednesday. All right.
Questions from last week?